Guys, welcome to the day 2 of interview preparation series. In the previous video, I have basically discussed two problems on dynamic programming from LeetCode, and you can see over here that we have actually 4 problems over here, and I think 1 problem over here. So looks like we have solved 5 problems, but the thing that I want to convey is that I did not upload the day 2 video because the feedback that you guys gave me, you asked that basically I should explain my approach a bit more. So just to handle that, I did not upload the day 2 video. So I still have that video, and I will just share the unlisted video with you in the video description. And today it should be day 3, but it will be day 2 video in the series. Okay, so this is how things are, and let's begin with this. Again, I'll keep these videos unedited because of like the simple fact that I want to highlight what are the steps involved in throughout the process, like opening LeetCodes, writing the solutions, trying that out on LeetCode, and then getting wrong answers. Then how do you solve those wrong answers? And just to cover all those things, we'll code without edited, and I hope this will be also allowing me to push more and more content frequently because it saves a lot of time. So I think it's a win-win situation, and yeah, let's move on. Okay, so again, let's solve dynamic programming problems. And one more thing that I feel I should do is that I should reorder this to day-wise structures. So because in this way it's difficult to track like what we solved first. So what I'm going to do is I'll basically have day 1, day 2 such folders because it's easy to track as well for you guys. Okay. Sorry for my bad throat. Okay, so we have solved a bit of easy problems. Now we have medium problems. Let's see what is this one. Minimum falling path sum, and maybe palindromic substrings as well. While this gets loaded, let's quickly do those movements. Okay, so I will say mk day 0 or day 1, and we will move everything from bit magic. So we should put a star over here. I made a mistake over there. I think I should also zoom in. So we bit magic star to day 1, and then also let's move from dynamic programming to again day 1. So star day 1. Alright, awesome. We can get rid of bit magic and dynamic programming, and now probably we can add everything to Git. Restructured the folders day-wise. Then we can also push this. Great. So now the GitHub repository should look day-wise. Alright. So guys, you have these 4 solutions over here, and now this looks good. Now we can basically have day 2, and now we are in day 2, and let's work. Okay. Alright.
It's 11 o'clock.
Okay, thanks for that, Mac. It's 11 o'clock. Given a square array of integers, we want the minimum sum of falling path through A. What is square array of integers? Okay guys, you can also basically pause the video or probably read the question with me. A falling path starts at any element in the first row and chooses one element from each row. The next row's choice must be in a column that is different from the previous row's column by at most 1. So basically it's saying that it's kind of an array. So it's saying something like 1, 2, 3, then it's 4, 5, 6, and then 7, 8, 9. So basically it's a 2D matrix, and we have to start from the top row and we have to go to the bottom row, and we can start from any column from the first row, but in each step we have to go one step down. And when we are going one step down, we can either go to the left column, to the right column, or to the same column that we are in. So one of the possible paths is 147, which is like the straight thing that we have. Then another is 148. Then we have 157, 158, 159. Then similarly 247, 257, sorry, 247, 248 is also valid. And 257 is valid, 258, 259. So yeah, that's the basic question, and we have to basically maximize, I think, the okay, so we have to minimize the smallest sum. That's the question. And the matrix length is 100, so we have around 10 to the power 4 total elements to deal with, and the numbers can be negative as well. Okay, so this is quite straightforward, guys, and let's quickly go to Visual Studio. Day 2, this problem is minimum falling path sum. Actually, I will have this 931.cpp because it's easy for you to track the problems on LeetCode as well. So let's have 931 dot, we can basically probably add dp.cpp. So 931 is the problem number from LeetCode. It's a dynamic programming problem, and we are coding in C++. Awesome. Okay, so this is what we have to implement. Just to avoid these errors, quickly import vector. Awesome. Using namespace standard. Okay. Alright, so we have a matrix that's in the input point. If you are not familiar with these vector things, I really recommend you to just go to YouTube, search over here Rachit Jain dynamic programming, C++ STL, and this is the first video where I cover C++ STL in 45 minutes. Also, again, for dynamic programming, you can go to my playlist. You can simply search Rachit Jain DP playlist. I think it should come up. Yeah, so dynamic programming from 0 to hero. Go through that. It has a lot of video content for dynamic programming, or you can stick around with these video series on coding interview preparation. We are at the day 2 today. But yeah, anyways, if you feel overwhelmed at any given point of time, simply go to the other resources that I have mentioned. Okay, coming back, so we have this array. So number of rows in this is nothing but a dot size, and the number of columns will be a of 0 dot size. So I pick the first row, and the size of that is the number of columns. Okay. Alright, so the thing that I want you to understand now is, like, we can start from any number or any column in the first row, right? So let's iterate on the first row, and we can say for int I is equal to 0, I is less than rows, I is less than columns, and our starting point is basically the ith column from 0th row. So this is our starting point, and let's say there's a function go which takes our row and the column we are at, and it returns the smallest sum. If we start from these locations, the 0th row and the ith column, and we go all the way to the bottom of the matrix, and it returns the minimum path to start the journey from x comma y till bottom of matrix. So till matrix bottom. Minimum path sum. When we start the journey from xy, so xy means xth row and yth column. So that's what co x comma y represents. In this case, we are starting from the 0th row and ith column. So the minimum path sum for that will be go 0 comma I. And basically what we want to do is we want to take the overall minimum. So we can have int answer as int underscore max. Then we have we consider all the starting points, which is 0, I, and we use this function go, which is responsible to compute the minimum path sum when we start the journey from x, y till the matrix bottom. So we get the answer for starting from 0, I, and we keep on taking the minimum overall, and finally we simply return our answer. So this should work. The only problem with this is, of course, we have not implemented the function go, so we need to do that. So int x comma int y. So when we are at this position, what can we do? One of the choice is, so like I'm really not doing anything. I'm simply doing the basic things that we could do, because you could start from any point from the first row. So I considered all those points. Now for given x comma y, I am understanding that I might be in the middle of the matrix. I don't care about the how I reached from the first row till x comma y. All I'm interested is in, if I start my journey, when we start the journey from x comma y, what is the minimum path sum to reach the matrix bottom? That's what I'm interested in. So case 1 is I can go to x plus 1 comma y. Like I really do not change my column. Another case can be case 2 and case 3. So the other case can be that I still go to the next row, because x will always go to x plus 1. We are always moving one row down. Y can be minus 1 in one case, and y can be plus 1 in one case. So these are the three cases that we have. Fair enough, this looks easy. So now what we can do is basically for each case calculate the answer and store the, so basically we can have int answer equal to int underscore max. We compute the answer for case 1 and take the minimum with so once we calculate the answer for case 1, we do this, then we do for case 2, then we do for case 3, and then we simply return the answer. I should probably hide this and also zoom in, because that's one of the other feedback that you guys gave me. Alright, I think this should look better. Okay, so what's next? Alright, so case 1 is we are going to x plus 1 comma y. So that's go x plus 1 comma y, and when we are x comma y, when we are at x comma y, we have already encountered the value at present cell. So basically what we can do is so matrix x comma y, that's the already cost that we have already added to our sum, and then we go to x plus 1 comma y, and this is the minimum that we will get from there. So this is what we will do. Of course mat is not defined, so we'll need to do that. So vector of vector int mat. So the problem is that I wanted to share this a. I basically wanted to pass this to the go function, which we can do. Actually that's a better idea. So this vector or the input matrix is in this function, and we are calling go, so it should have access to that. So I'm adding that as a parameter over here, and we will need to pass this as reference, guys, so that C++ doesn't waste time in creating a copy of the matrix in the recursive calls. And to do that, to tell C++ to copy smartly in order one time, this is how you do. So basically the same matrix is passed over here, not a separate copy. Okay, yeah, so we can again pass that to this function, and yeah, that's pretty much it, guys. That's all you need to do. So let's quickly do it over here, and let's also do it over here. I really feel that I'm going super slow, but that's what you wanted, so that you guys do not miss out on how to do things, and I really hope that we can speed things up in the future. Of course it's day 2, so we can go slow. I'm fine with that. Alright, I think this should work. X plus 1, y plus 1, everything. We have considered all the cases. The only problem with this is that we have not considered the edge case. So let's quickly do that. Okay, so if x is a dot size, so basically we have exceeded the bottom row as well. The last row in the matrix is a dot size minus 1 because 0 based indexing, guys. So if that is the case, if x is a dot size, we simply return 0 because we have no minimum, so the path sum is 0 in this case. And another thing is about the column. If y is a 0 dot size, this can be actually tricky. So guys, hear out very carefully. If you return 0 over here, it will actually throw a wrong answer. And the reason for that is when you are at this matrix. So when y is basically exceeding the column range, so it means that you might be at 3 and you are trying to go to the right side of 6, which does not exist. And if you return 0 over there, that will say that it takes 0 energy to go from this row to this row. And the final answer that you will get from when you are starting from this 3 is basically 3 only, because 3 plus 0 and then from here you got a 0. So 3 plus 0 is 3, so that will become an invalid answer. It is small but it's not right. So if you are trying to go to the right side of the columns, you should return int underscore max. That's a penalty. Like, it's the maximum integer, right? Of course it should not be int underscore max, because when you try to add things up with matrix of this, it will overflow. But what you can do is add a very great value. So something like, maybe you can have over here constant infinity is equal to 1e9 or 1e8. That's still huge because the matrix is fairly small. And now what you can do is, instead of returning 0, you can return infinity. Another thing is that y minus 1 can also become minus 1 when y is 0. So even in that case, or y is minus 1, oops, you should return infinity. Similarly, when you are at 4 and you are trying to go to the left of 7, that's again an invalid move. So I give you a high enough penalty so that when you are taking this minimization over here, that option will immediately get ruled out. That's what I'm trying to do. Awesome, I think this should work. Let's quickly copy this much. Go to LeetCode, paste it. So when I'm saying that we are going super slow, I mean that when we are practicing alone, we might want to go a little bit fast. But since I am actually trying to teach you as well, and actually this is how you should also approach questions in interviews. So in that sense, I think we are not going that slow. Okay, so runtime error, what is it? Line 923. Okay, so it's not from our file. Reference binding to null pointer of type struct value type. So LeetCode has been giving me really weird errors that I am seeing for the first time in my life. So what is it that I am doing wrong? I am passing that as an argument. That's no problem, I think. Is it that if A is empty or something, return 0? I'm not sure if it was because of that. Okay, it's not because of that, but still it's a good corner check that we should add. So what can be it? First I will go over here and add this to this code. And guys, these are some things which companies like Microsoft pays a lot of attention. Corner cases. So you have to write code which is production quality, because you might not be aware of how clients will use your code. So make sure to have all such cases handled. Coming back to this error, we need to work it out. I'm not quite sure why this is coming, because according to me it should work. Let me try some test case. Okay, so this is a test case. So it's not working for this. So let's quickly debug line by line what might be going wrong. So this is no problem, this is no problem. Actually we are not using this, so we can get rid of this. Actually we are using it. Okay. Yep, this sounds good. I think this should work. Most probably it's happening because of passing this only, I think. Which should not be the case. Like, it should allow us to do that. Runtime error, reference binding to null pointer. Pointer. Guys, I'm really not sure why this is happening. Let's try one thing. Let's make this A. Or I really didn't want to do this, but guys, yeah, I'm really sorry. I've been doing this from the past few videos in LeetCode. So whenever you are trying to use such recursive functions, guys, I'm sorry. What you can do is, because they are not allowing all these things, I'm not sure why this error is coming. So the only way that we can do is basically copy this vector ourselves into our local copy for this class over here. So let's call this as mat, and what I'm trying to do is basically A is equal to mat, right? So that's what I'm trying to do. Of course we don't need this now. I'm not passing anything. Oh, okay. So this was the problem, I think. We were passing A and we are using mat over here. Damn, this was bad. My mistake, guys. Let's get rid of this. Let's try to run the code. Sorry guys, that was my bad. Alright, so this seems to work, but if you try to submit this, of course this will give us time limit error. We are not using dynamic programming, which we can. But just to let you know that you will get time limit exceeded, here is that red marker which is saying time limit exceeded. And to solve that, basically first I need to copy this and paste it over here because I've made a few changes. Let's basically solve that first. Alright, so we have pasted back the code, we are back, and now let's introduce dynamic programming. And before we do that, I think I should commit, so that I also got this feedback that please try to have both your solutions on GitHub, one without the DP, just the recursive thing, and one with the DP as well. So let's quickly go to the terminal, clear the screen, git status. Alright, git add day 2 star, git commit -m, oops, problem 1 day 2, problem 1 day 2 DP recurrence, and then we will basically introduce dynamic programming, and then I will have another commit for that. So basically when you will go to the GitHub repository, so I will first do that and then then tell you how you can look at both the changes. Okay. Alright, so let me introduce the dynamic programming stuff. And what you can do is have something like vector of vector int and call that DP, and then what we can do is basically also have another memory for visited, storing that we have visited this or not. So let's call that visited. Okay, and over here we have calculated the rows and columns. So what we can do is dp.resize, we want these many rows, and what we want is these many columns filled with 0. So that's our DP initialized to 0. I think it should be initialized to let's say int underscore max. That's I think better. So initially we are saying that to start from any cell I comma j and to reach the bottom it takes infinite energy. That's what we have said. Alright, so basically the meaning of go xy that we had over here, it's still the same. It's just that dpx comma y will store what go x comma y will return. So dpx comma y, actually it's dpxy. Oops. Yeah. So this will store what go x comma y will return. And this is what dynamic programming is, that if once we compute what go x comma y is returning, we store that in some memory address. That's what we are doing. So the next time when the function comes at computing go x comma y, We do not do all those calculations again and again, we simply return this value. So to do that, we go back over here and let's quickly do that. What we can do is int and answer is equal to dpxy, and then what we can do is if visited xy, we can simply return our answer. Otherwise we calculate the answer and we simply return the answer at the end. But before we do that, we mark that we have visited x comma y. That's it. And another thing that you need to do is this is visited.resize. Initially we have not visited anything, so this is 0, and that's all you have to do. I think this should work. That red colored time limit error should now go away if we do not get any errors. Yay! So this has been success. Let's open the terminal, git status, git add. Oops, what I'm doing. So git add day 2 star, git commit -m. So now it's day 2, problem 1, dp main solution. So that's it. And then I push to origin master, not mater, master. Alright, so what I did over here is that now if you go to GitHub repository, you refresh this, you will see a folder day 2 over here, and once you click on that, now you can see this one file 931.db.cpp, but it will have basically, if you go to the history of this, you can see that there are 2 commits. If you click on the recurrence one, you will get the recurrence solution. If you click on the main one, you will get the final DP solution. So this one was the basic. This one was where we do not have DP introduced, and this one is where we have DP introduced, right? And these are the changes that we made for that. So guys, it's so easy. You can first have your recurrence solution ready, and to convert that into dynamic programming and to get rid of that time limit exceeded error, you simply introduce this. Guys, I think this was a fairly good thing that we did. Beautiful journey from scratch. I think people who were not clear with dynamic programming, now you have a fairly good idea. So in the next problem, we might go a little bit faster. Alright, let's go to the problem 2 and then we can quickly wrap this up. Given a string, your task is to count how many palindromic substrings in the string. So guys, it's a fairly straightforward problem. If the string is s, its length is n. Again, I will zoom in a bit so that you guys don't complain about all these things. Just kidding. Okay, so let's say there is a string s and the length of that is n. In mathematical world, you denote that as this: mod of s is equal to n. So the length of the string is n, and the question is how many substrings of it are palindrome. So first of all, there can be up to n square substrings. So we can say order n square substrings. We are not interested in finding the exact formula because that will be NC2, and if we are even counting a single character of this string s as a substring, then there will be more than that. Okay, but substring, if you are counting it, it is order n square. That's what I mean to say. So out of these order n square substrings, the question is to count the number of substrings which are palindrome. So let's quickly see some examples. So if it's AAA, actually anything that you pick will be a palindrome, right? Palindrome is nothing but if you read the string from front to end or end to front, it's same. For example, Sahas, it's a famous Indian boy name. If you read it from starting to ending, it's Sahas. If you spell it backwards, it's still the same. So it's a palindrome. Okay, sorry for the bad throat, guys. I'm not sure why this is happening. Alright, I'm back. Okay, so how do we proceed with this? So what we can do is we can iterate on all the n square pairs of the substring that we have, and to check whether a given string is substring, it takes order n time. So the total time complexity of the brute force solution is order n cube, and the input length is up to 10 to the power 3. And here is something interesting that you might not be knowing. Let me add in the alright, so let's quickly go to cd day2 and let's quickly add a file. What is the number for this problem? 647. Alright, so touch 647.dp.cpp, and then we can basically open that 647. Alright, let's close the terminal. Okay, so what I mean to say is, if you have n is equal to 10 to the power 3, and if you are trying order n cube, this will be around 10 to the power 9. And make sure that in the world of coding interviews or competitive programming, only solutions which go up to the 10 to the power 8 operations max get accepted. So if you try this, this will not work. This will give you a time limit error. And I will have this in the GitHub repo so that you can check that out. And the task that we have to implement now is order n square, because that will be nearly 10 to the power 6. This is what we have to implement. Okay, I thought that most of you guys might not be knowing this, so I shared this out. It's actually good to also figure out what is the time complexity that you might be expecting. So if n is 10 to the power 5, the solution is not, of course, n square. It will be n log n kind of thing. Okay, so that's the main intent that why I shared this. Again, guys, sorry for the bad throat. Give me a second. All right. Palindromic substrings. Int count substring string s. So hash include iostream using namespace standard. Okay, so we have to do something better than brute force, which is taking order in cube time. One of the thing is that we can basically do for int I equal to, basically first store int n is equal to s dot size, then do I equal to 0, I is less than n, I plus plus. For int j equal to 0, j is less than n, j plus plus. Actually, j should be I, right. And we can do answer plus equal to go I comma j, and then return answer. Then we have int answer equal to 0, and that's it. This should work. Alright, I hope you have understood everything, and let's quickly submit this and check if it's working. Just kidding, guys. So what is go ij now? So this returns whether the substring si up to j is a palindrome. And for this to be a palindrome, what we actually need is if si, let's also pass the string and pass it by reference. Don't forget that, otherwise it will take a lot of time, because for every call to go function it will create a copy of string. So we don't want that. What is sig action? Oh my god. So if si is not equal to sj, guys, can this be palindrome? Of course not. So we return false. If that is true, so si is equal to sj, we can simply return go I plus 1 and j minus 1. So if the substring I plus 1 till j minus 1 is a palindrome, then of course I till j is also a palindrome. Wow, that's a fairly straightforward solution. And since we have only n square states, because this I can go up to n, this can go up to n, so we have n square states. And over here, for every state, we are not doing anything fancy. We are simply going to one of the other states in order one time. So the total time complexity of this will be order n square if we use dynamic programming. Because once we store for some go, we store that into some dp variable and we simply return it, right? So let's quickly do that, and we are getting an error over here because we are not passing s. Let's not forget to do that. If I is equal to j, we can simply return true, because any string of length 1 is a palindrome. Okay, so this is fine. Let's also have the vector of int. Again, guys, for these vector things, don't be afraid of that. My C++ STL video, C++ STL video, I have just 2 videos in that, but they are so wonderful. It will get you like really good with C++ STL for coding interviews, guys. Do check that out. Okay, check my playlist. Yeah, it's saying there is an error. Let's quickly have a vector over here. Okay, so and we also need the visited thing, so let's do that as well. And over here we want dp dot resize vector, sorry, oops, n of size n, vector of int n comma, let's have -1. And then we can have for visited, we can push that as 0. Alright, okay, so now what we can do is int and answer equal to dpij. If we have visited ij, simply return our answer, else before returning answer is this, oops, answer is this, and let's mark this as visited. This is wrong because we might return over here without marking this, so let's mark it over here. Alright, so now if we have visited it, we are returning it, otherwise we are saying that we have visited it. Yeah, that's it, guys. That's pretty much it. It should work, and let's quickly copy paste this. And now we should not even get the time limit exceeded error. We have already introduced dynamic programming. Okay, wow, I am sure that I did not write this. This is autocomplete of Visual Studio. Thank you so much. Oh, this is Wiz. Again, guys, what is this? It doesn't really let me type. Wiz. Visual Studio LeetCode is also like really giving us weird errors today. Heap buffer overflow and address at PC. Okay. So what is it that we are doing wrong now? Everything is looking good to me. What is it, guys? What is it? Let's try it for some test case. Let's try for this. Run code ABC. It's working for this. It's working for this. So what can be wrong? Okay, I think when the length of the string is 2, and let's say it's the ith and jth characters match, so we do not return over here, then we are doing I plus 1 and j minus 1. So over here what we should do is if I is greater than j, right, because that might happen when the length of string is 2. So if I is greater than j, we can simply return, now we should return 1 over here. And now let's submit the code. Wow, success. Awesome. Guys, I think you will master dynamic programming very soon because it's really not that hard. Alright, let's open the terminal. Of course, we are not having any 2 versions for this, so we just have 1. Let's quickly add day 2, problem 2, dp main, git push origin master, and that's it, guys. I hope you enjoyed this, and I will see you on the day 3 very soon. Again, for the one of the videos that I have not uploaded, I thought that your feedback was important and I should inculcate that. So I did not choose to upload that video, but I will have the link to that in the video description. So if you want to check out the solutions for the other problems that you can see in the day 1 folder, let me go to day 1 and quickly show you that. So we'll go to day 1, you will see 4 problems I think, but we have only discussed 2 problems in the day 1 video. So for these other two videos, you can check out the solutions and again the complete walkthrough for that in the unlisted video in the description. And if you have any other doubts, guys, let me know in comments. Go through the channel. These playlists are pretty good, I think, and I'll see you next time.